Welcome. In this video we're going to be learning about Born-Haber cycles. So here's a reaction: sodium and chlorine form sodium chloride. And here's another reaction that also forms sodium chloride. So both reactions form the same ionic compound. However, we can see that in the top reaction we have sodium and chlorine in their standard states. This is called enthalpy of formation. In the bottom reaction, we have gaseous ions which combine together to form a solid lattice. So we call this lattice enthalpy. Let's say we know the value of enthalpy of formation. However, we want to work out the lattice enthalpy of formation. One way to do this is to create a Born-Haber cycle. So for any cycle, we need to have a clear starting and ending point. We'll pick sodium and chlorine as our starting point, and the end point can be sodium chloride because it's present in both equations. So one way to get from the start to the end is like this, via enthalpy of formation. The other way is to go down this route. Okay, for the second route, we have to first convert our sodium solid and chlorine gas into gaseous ions. So let's start with sodium. First, we're going to convert it into a gas. This is called atomization. Now, as for chlorine, although it's already a gas, it's a molecular gas, a Cl2 molecule. So we again have to convert that into a gaseous atom by doing atomization. Perfect. Now we have sodium and chlorine as gaseous atoms. The next stage is to turn them into ions. So if sodium is going to turn into a positive ion, that means it will lose an electron. So this is called the first ionization energy. As for chlorine, it's going to turn into a chloride ion by gaining an electron. So this is called first electron affinity. Once we have our ions, we have now completed the cycle. So let's have a look at how this would look like in a real example. In the bottom, we're going to put sodium chloride solid, our ionic compound. On the left, we have sodium and chlorine in their standard states, and on the right, we have sodium and chloride ions. And this arrow represents lattice enthalpy of formation. So one way to get from sodium and chlorine to sodium chloride is by going down formation. And of course, this will have a enthalpy. Or the other way is to first convert it into gaseous ions and then go down lattice enthalpy. Of course, these will also have their own enthalpy values. Now, since we're going from the same reactant to the same product but through different routes, we can still say that Hess's law applies. So the red enthalpy is equal to all of the green ones added together. Okay, let's try an example then. Here is an incompleted Born-Haber cycle. On the left, we have formation, and on the right, we have lattice enthalpy of formation. So we want to first start by converting our sodium and chlorine, which are in their standard states, into gaseous ions. So let's start with sodium. Here it's a solid, but over here it's a gas. That means we have to do atomization, when 1 mole of gaseous atoms are formed from an element in its standard state, such as converting sodium solid into sodium gas. So this arrow represents atomization of sodium. Notice how the sodium has gone from solid into gas, however nothing's happened to chlorine just yet. Okay, so we're not finished with sodium. Here it's a gaseous atom, but here it's a gaseous ion. That means we have to do the first ionization energy, which means creating 1 mole of gaseous plus 1 ions from 1 mole of gaseous atoms, by ripping off electrons. And this arrow shows that sodium has been turned into a positive ion. This is the first ionization energy of sodium. Okay, so we finished with sodium. Let's have a look at chlorine. On the left, we can see that chlorine is a gaseous molecule. However, we want it to turn into an atom. So we have to atomize chlorine. Okay, so we've atomized chlorine, and now you can see that we have 1 mole of gaseous chlorine atoms. The next step is to turn chlorine from a gaseous atom into a gaseous -1 ion. To do this, we have to do the first electron affinity, which is when you create 1 mole of gaseous 1- ions from 1 mole of atoms. Now, pause for a second. If we convert chlorine from an atom into an ion, what will we have now? We'll have a sodium plus ion and a Cl- ion, which is basically what we have at the bottom right. So we don't need to go up anymore, we can just extend our line and point down and say that after doing the first electron affinity of chlorine, we have now completed the Born-Haber cycle. Perfect. Now in the question, they will give you values for each of these enthalpies. So let's say we've been given all the values except for lattice enthalpy of formation, and we want to work this out. Now to work this out, here's how you use your cycle. First of all, you want to pick a line which has two arrows pointing away from it. There will always be one line that has two arrows pointing away from it, and it's this one. You can see that one arrow is going up and one arrow is going down. Next, you want to pick another line which has two arrows pointing towards it. And again, it's going to be this one. Formation is pointing towards it, and so is lattice enthalpy of formation. Okay, so to go from the top red arrow to the bottom one, you have two options. One way is to go through formation, which is minus 411. The other way is to follow the arrows until you've gone round your cycle. Now we can say that minus 411 is equal to all of the other arrows added together because of Hess's law. Of course, we don't know the value for this, so we're going to make this the subject. So we're going to add all our numbers together, and then we get a final answer of minus 787. And this is the value for the lattice enthalpy of formation. One more thing, notice that all the arrows that point upwards are endothermic reactions which take energy in, and we can see that they all have a positive value in front of them. Arrows that point downwards are exothermic and they have a negative value. So the fact that we got minus 787 means that we've done it correctly. Okay, some final points. Here we have two reactions. In both reactions, we start with sodium solid and we end with a sodium gaseous plus ion. However, only one of these reactions is the right sequence, and it's the top one. So that means you always have to atomize first before you do ionization or electron affinity. Because remember, the definition of ionization is when you form 1 mole of positive ions from 1 mole of gaseous atoms. So you need to have a gaseous atom before you can ionize or before you can do electron affinity. One more thing. Don't forget to multiply your enthalpy values. So here's an example. Let's say the enthalpy of atomization of chlorine is plus 122. Here we have two atomizations of chlorine. The first one, we're atomizing an entire chlorine molecule, and that gives us 2 chlorine atoms. In the bottom one, we have half Cl2. So when you atomize that, that gives you 1 Cl atom. So in the bottom one, we've created 1 mole of gaseous atoms. That means we can just say 122. But in the top one, we've created 2 moles of gaseous atoms. That means we're going to have to multiply our atomization by 2, and that value is 244. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.